Welcome. In this lecture, we will solve the midterm examination that was conducted online for our course circuit analysis. Question number one is for this circuit shown here in this diagram, you were asked to compute Z Thevenin. Well, to compute Z Thevenin for this circuit, we have to remove this load and this replace this current source with its equivalent resistance. The equivalent resistance of the current source is infinity. So this would be replaced with an open circuit, and we will remove ZL and we'll find Z Thevenin across these ends. So I have solved it for you by replacing this. If we replace it using if we replace it this circuit, this 1 ohm resistor goes out of this circuit, because when we replace this with open circuit, this 1 ohm resistor is no more in the circuit. Now we have only 1 ohm and J1 ohm in parallel that we have solved here, plus this minus J1 ohm would be in series with this parallel combination. So with this parallel combination, this is in series, so I solved it, and it comes out to be 1 minus J1 over 2 ohms. This is Z Thevenin. And in the next part, we are asked to put ZL is equal to Z Thevenin, not equal to its complex conjugate as we did for maximum power transfer theorem. Right, so we have to put ZL is equal to Z Thevenin. Instead of putting it Z Thevenin static, we have to put it ZL is equal to Z Thevenin. So I have put ZL is equal to Z Thevenin. 1 minus J1 over 2 is Z Thevenin, so I have replaced DL with the same impedance. ZL is Z Thevenin. Instead of replacing it with its complex conjugate. And then I have applied nodal loop analysis. When we apply loop analysis, I1, we assume current I1 for this loop, I2 for this loop, and I1 is minus 1 because this loop contains a current source, and if we have a current source in a loop, we don't write KVL equation for that. Instead, we write I of that loop to be equal to the current of that current source. If they're in the same direction, we'll write it positive. If they are in opposite directions, we'll write negative. We already know that. And for this is equation number 1, and for equation number 2, for loop 2, we have to write equation minus J1 and 1 minus J1 by 2 and J over 1 plus J1. I2 current flows through these impedances clockwise and I1 counterclockwise. Therefore, put a negative sign here because I2 is going downwards, I2 is going upwards. So we'll write a negative sign with I1, and we are in loop number 2. Therefore, we'll assume I2 to be higher. Right, and then we have solved it using some basic mathematics involving complex arithmetic, and we come up with I2 is minus J.5. Since IL is opposite to I2. Why is it opposite? Because I2 is in this direction. We are asked to find polarity in a direction where this terminal is positive and this terminal is negative. So the current that will cause this polarity will be opposite to the current I2. So IL should be the opposite of I2. IL is minus I2, this one. And then VL is computed using Ohm's law, J2 times the current flow. J2 is the current, 1 minus J1 over 2 is the impedance. So this is I, this is ZL. So I times ZL gives us VL. So in fact, IL times ZL. Right, and we have computed power, and we have used a term 1 by 2 here because we know that the quantities we are dealing with are all peak quantities. If they are RMS quantities, we don't have this 1 by 2. We have already studied. Right, and we have solved part number 1, part number 2, and part number 3. We have completed VL, and we have solved part number 4 too, because we have completed PL. PL is 1 by 2 times the magnitude of voltage times the magnitude of current times the cos of angle between voltage and current. So it comes out to be 1 over 16 watt. Right. Let's move on to the next question. That is, for the circuit shown in question number 1, this circuit, what is the power factor of the load? To find power factor, we know, to find power factor, we know power factor is cos of the angle between voltage and current. By definition, we know that this, by definition, power factor is the cosecant of angle between the voltage and current, right? So we have just computed that the voltage, angle of the voltage is 45, angle of the current is 90. 45 minus 90.707, and whether it is leading or lagging, right? If the current is lagging, it's lagging. But we see that the current is at 90 degrees, voltage is at 45 degrees. So current is leading. So if the current is leading the voltage across it, of course, this is a leading power factor, right? In part 3, in part number 1, we have answered the power factor. Is the power factor leading or lagging? It's lagging. And what's the new power factor if we connect a resistor of value 1 ohm across ZL? I've also solved it for you. This is the situation that we have the same ZL, but now we have a 1 ohm resistor connected across this load. So this requires a bit mathematics involving complex algebra. So ZL new would be this impedance in parallel with this impedance. So Z1 times Z2 over Z1 plus Z2. If you solve it, the new ZL comes out to be this 1 minus J1 over 3 minus J1. And then we have to compute the new, since we have to compute the new power factor in this new load, we have to find voltage across it and the current going through it, and then we will compute cosecant of the angles between the two to compute the new power factor, right? So I1 is, we'll apply, once again we apply the loop analysis. I1 is -1, and then this whole stuff, through this we, a current I2 flows through all these impedances. A current I2 flows clockwise and I1 current flows counterclockwise. We put the value of I1 here in fact, and we solve it using the complex algebra until we reach a new value of IL, that is 0.36, that is 0.36 at an angle of 125 amperes. And VL new is IL new times ZL new, like we did before, and VL new comes out to be this much volts. And power factor new is now simple to calculate because we have the angle for voltage, the new voltage, and we have the angle for new current. So the cosecant of the new angle of voltage minus the new angle of current gives us the new power factor 0.89, and this is also leading. Why leading? Because VL has an angle 99.33, and let's see what is the angle of current. This is 125, so 125, this means it's larger compared to the voltage, angle of the voltage. This means it's a leading, current is leading. So if current is leading, power factor is also leading. Right, so we have right now, we have, till now we have completed 2 questions out of 3. Now the third question is very simple. We have to find, given this voltage f of t plotted versus t, we have to find its average value and its RMS value. To find the average, first of all we have to figure out what is the time period of this wave shape, right? It seems it's 2 pi. Definitely it is 2 pi, because after 2 pi the signal tends to repeat itself. So 2 pi is the time period, and we know that to compute the average value of a signal f of t, we divide it with this time period, integrate over the whole time period, and if it is required we break this integral. If required, we break this integral into many parts, into more than one parts. So here in this case it is sine 2 sine of t from 0 to pi and minus sine of t from pi to pi, because this is the part of this voltage. This is the part of this voltage. So this is minus sine of t. So minus sine of t from pi to 2 pi. And then this requires simple mathematics, the integration that we have studied in elementary classes, unless we reach to a value f average is 3 over pi. But pi is 3.14, so 3 over 3.14 is around zero point 0.9 something, 0.9. So the value is 0.9. The average value is around 0.9 because the value of pi is 3.14. 3 over 3.14 gives us 0.95, 0.96, something like this, maybe 0.96, right? And the second part is, in the second part we have to compute, in fact, in the same part, the second portion of the question is that we have to compute FRMS for the same signal, right? So time period remains the same, 2 pi, and we have to compute FRMS, and we already know that we apply these three operations: root, mean, squared, in reverse order. We first square the signal, then we compute mean, and then we apply root, where root is square root. So we have squared the signal and we have to divide the signal because the definition of the signal is different in different intervals. So 0 to pi, it's different than it is from pi to 2 pi. So we have to square the signal in every interval, and then we have to compute its mean, because we are computing mean because we are integrating it from 0 to its time period, along it over its time period, and you dividing it with the time period too. And then finally we are computing this square root. So solution is requires trigonometric identity that sin square t is 1 minus cos 2t over 2. It's half angle formula from trigonometry that we have studied in elementary classes, schools, and colleges. Sin square t is 1 minus cos 2t over 2. So we have replaced this with this double angle and to get rid of this square term. So then we solve it using the elementary mathematical techniques, involve simple skills to compute integrals of the functions of time, and then we come up with this, a value slightly greater than 1. So this is FRMS. That's all for this lecture, and we will continue with our regular class work from our next lecture. Thank you.